first video on the channel, of course, we got to do two-sum. Basically, on this channel, I'm just going to be doing a bunch of LeetCode problems, just walking through them, showing, talking about how to solve them, talking about the space and time complexity, and then just of course, writing the solution. I'm going to be doing all of these in C++ because it's my most comfortable language. I do apologize if I make any mistakes in these videos. Please let me know in the comments. I'm also trying to grow through this process. But anyways, yeah, let's just get right into it. So for two-sum, basically, let's discuss the problem. So we're basically given an array of integers called nums, and we're also given an integer target, and then they want us to return the indices of two numbers in that array that add up to the target they give us. So, and then some assumptions, they say that we can assume that every input is going to have one solution. No more, no less. So that gets rid of, the edge cases where there's more than one solution, or the other edge case where there's no solution. So that's handy. We can't use the same element twice. So if the target was 4, we can't use 0, 0. Basically, we can't return this 2 of the same index. That's not allowed. But we can return the answer in any order. So that's another thing to consider that kind of helps with some ambiguity maybe. So, but anyways, yeah, this is a really popular problem. So it's a good one to know just to get kind of familiar with hash maps. And who knows, maybe you get lucky and get this one in an interview. So anyways, basically the naive approach here, let's look at some of these IO cases. Thankfully, there are a few already written up for me, so I won't type them out. But let's say we have this array of numbers, and then the target's 9. So basically, we want to find two numbers in this array that add up to 9. And we know there's always going to be, the answer is going to be in there once. So, right away, we could see 2 and 7 add up to 9. And again, we're returning the indices as a vector. As we can see here, just a vector of integers. So, and that's going to be 0, 1, of course, because, the index of 2 is 0 and the index of 7 is 1. And then basically, all of these... sorry about that. These other two examples are pretty much the same. So, so the naive approach here is going to be to basically do a nested for loop. So the naive approach is a nested for loop. The solution works. And the way it would work is you basically gonna, have you're going to compare this number to every other number in the array and basically see if any of the other numbers add up to, with the number you're looking at, if it adds up to the target. So the problem with that is you can imagine as the array gets really large, you're going to have to do that for every single number and then all the remaining numbers. It's bad because it's going to be n squared time complexity. And you can just imagine how slow that's going to take. So, I'll just put naive approach nested for loop. And the time is going to be big O of n squared because it's asymptotically bound by n squared. Depending on how you implement that. But either way, it's too slow. There's a better solution. We could take advantage of the data structures that exist in C++ and, other languages. Basically, we're going to use a Hashmap for the optimal approach. Basically what that means is we can store numbers that we've already seen and then look them up in constant time. Which allows us to reduce the time complexity of this solution to linear, which is really good. So hash map, hash table, whatever you want to call it, in C++, we're going to be using an unordered map. So the time complexity for the hash map is going to be big O of n, which is much better, much faster. So let's just go ahead and implement this here. So unordered, we're going to use an unordered map, and the types are just going to be int. The key is, well, actually, I do tend to get mixed up about which one is the key and the value here. So I'm going to start implementing this, and then I'll go back and clarify which is which here. But but basically, we're going to be storing the key and we're going to be storing like the value of the element, and then the index of the element. You know, it's like a corresponding pair pretty much in the unordered map to keep track. So I'll just call this this Hashmap map for, you know, simplicity, and then we also need a vector because we're returning. We need to return a vector for the result. You know, for those two indices. So we're just gonna do vector of integers. I'll call it res, and actually we can speed this up a little bit more because the vector constructor actually takes a one of the parameters is, you know, the size of the array. So you can actually initialize that beforehand, you know, without appending the elements, which is slightly faster because then you can just assign them. It already has the space allocated. So we're gonna do that, and then basically we're gonna have a for loop here. Typically with for loops, I like to use auto, but for this one, the indices are important, obviously. And so for me, it's a little bit easier to just do it classically like this. So like a C style for loop. So basically, we're just gonna be iterating through all of the numbers in nums. So, you know, this is our starting index, 0. And then we're going to be increasing I while it's less than the size of the nums array. So, and then there's us increasing I here with I++. So basically, so imagine you're at the first number of the for loop, right? It's like, what do you want to do first? You are looking at, so like for this array, you're looking at 2, and you're like, okay, well, you know, we have a hash map, and we need to see what is the other number that adds up to 2 and equals 9, and does it exist in our hash map? So first we need to get that number. So to get it, I'll declare integer other num, and that'll just be target minus nums I. And then now we want to check if this exists in the hash map. So we just use a if statement here, and to check if something exists in a hash map in C++, you can just do if map.contains, it's just a method on the map data structure. If it contains, we're going to be using the key here. So if it contains other num, then we can basically just set the values of our result array. So we could set the first index of that array to be, you know, the index of the other num, which is going to be the value in that map. And then obviously the other index is just the number we're currently at. So we can just say I. And then we just return res there. So that's the case where we find the result. Now, what about the other case when we don't find the result? Basically, we just want to store the element and the index that we're currently at in the hash map, so we can keep checking, you know, as we iterate through the array. You know, here for that case, we'll just do map other num, or my apologies, map. It's actually going to be map nums I, because it's the value of the element we're currently at, and then we set the value in the map to the index. And then just so we're returning something in all control paths, we have to return res here also. And to make sure we're not getting weird values, I mean, this would never be reached because we know there's going to be one solution, but usually if there's an answer is not found, like you'll return like -1. So I'll just have it do that for clarity. But yeah, this is basically the solution here. Now I'm gonna look at it briefly to see if I made any bugs or typos, but looks mostly good to me. So we can go ahead and run this. And did I make a mistake? Doesn't look like it. So as you can see, all the test cases passed. Again, this is going to be linear time, and then the space complexity is it's not going to be constant. We're also going to be doing big O of in space, because we're gonna need enough space to have a hash map that basically grows linearly corresponding to the size of nums. So, but yeah, big O of in time, big O of in space, pretty clean solution. I'll just submit this to see, the percentages here, but 8 milliseconds beats 80%. Pretty good. I like, this problem. I think it's a really good one to get familiar with Hashmap. So hopefully this helped. If there's any improvements that could be made in my code, please leave a comment, and also please leave a comment and like if this helps you out. So I know to keep making these. But anyways, yeah, thanks for stopping by, and I'll see y'all in the next solution video.